Welcome back to question 2 of our series on hypothesis testing of pair-dependent data. This time the question reads, a consumer group wishes to compare two brands of tire, brand A and brand B, with respect to tire wear. One of each brand of tire was randomly assigned to the rear wheels of 8 cars. The cars were then driven a specified number of miles. The amount of wear on each tire was recorded. Take a look at the table. We have cars 1 through 8, this is the wear for brand A, the wear for brand B, and this column represents the differences, where we take this number, subtract that number. Assuming that the simple random sample is normally distributed, test at alpha is equal to 0.05 if, on average, brand B wears more than brand A. That being said, let's start off by writing out our hypothesis. Our null hypothesis will be the opposite of what we're looking to find. That is, the wear of A is more than that of B. And the alternative is the opposite of this, where the mean of group A is less than that of group B. In other words, the wear of this brand is more than A. To test this hypothesis, we'll be using a t-test. And the reason why we're using a t-test is because, for two reasons. The sample is actually quite small. We have 8 cars. And another reason is because we are told that it's normally distributed. A t-test is a parametric test that is able to combine these two features. To calculate this test statistic, we use the formula shown right here. And what we have to do is find out the t-observed value and compare it to the t-critical, which we find in a table. The formula is the average of the differences. So we need to take the average of these numbers. I've already gone ahead and done it for you. I'll write it down right here. You should end up with negative 0.5. And just so that we're clear, I added up these numbers and divided it by 8. Next we have mu d, and that represents the difference in the means. So if we look at our hypothesis, mu A minus mu B represents mu D. And if we relate that to the null hypothesis, that means we can replace this value with 0. We can start to fill this in. T observed is equal to the value we found earlier as negative 0.5 minus 0 over, now we have to find the standard deviation and divide it by the square root of the number of observations. So we know what that is. It's the square root of 8. To find the standard deviation, we will use this formula, and this requires that we find the sum of these values. In addition, the sum of each of these values squared, because those values will then be placed into this formula. The sum of these values is equal to negative 4, and squaring these and then adding them all up should give you 4.1. Now taking those values and placing them into here, we get 4.1 minus 4 raised to the power of 2 divided by 8 over 8 minus 1. The value you get after computing this, and of course square rooting it because this is the variance, you need to square root it, goes into here, and it should equal to 0.54. Calculating our t observed, we have negative 0.5 minus 0 divided by 0.54 over the square root of 8, and that gives us negative 2.61. Negative 2.61. Now because this is normally distributed, we have a chart that looks like this. To find out the t-critical, we will use degrees of freedom of 7, because 8 minus 1 is 7. So t-critical at an alpha value of 0.05 and 7 as the degrees of freedom. Your chart should give you negative 1.895. On this chart, negative 1.895 is over here. And anything to the left of this is the rejection region. Negative 2.61 goes well beyond that. This means that we have to reject the null hypothesis. And we can reject the null hypothesis because we have enough evidence at 95% to favor this one. What does this tell us? That there is more wear in brand B than there is in brand A. So make sure that you write that conclusion down, something along the lines of there is sufficient evidence at an alpha level of 0.05 to conclude that tire B wears more than tire A. And there you have it. Another example on how to use the t-test for paired data of two dependent populations.